Hey everyone, today guys I wanted to talk to you guys about a very important number, which is 3248 factorial. Now why exactly do I think that this number, why do I believe this number is very interesting in fact? Well, the reason for this is because it's the largest number my computer can calculate, the largest factorial number. My phone can calculate an even larger one. However, this one is the largest, which is 1.973634253086042531204708003401 times 10 to the 9997. Now this number is already very big, and it's a factorial number. So what is a factorial number? Well, a factorial number is, let's say you have 3 items. Now, how many ways can you arrange these 3 items? So to calculate this, you just multiply them 3 to the lower integers times 1. And then you get 6. So that's 6 ways to arrange 3 items. For example, I can go 1, 2, 3, 1, 3, 2. Wait a minute, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, 3, 2, 1. And every possible outcome is already put in there, so you cannot say anything else. It's already added. How about thinking like saying 2, 1, 3 or 1, 3, 2. 2, 1, 1, 3, 2 is there, and 2, 1, 3 is there. So yeah, they're already added in. But the reason why 3248 factorial is really good, interesting, is because it's the largest number my computer calculator can calculate. If I go to the next number, which is 3249 factorial, I get an overflow. As the numbers become too big for my computer calculator to handle. So that's why I do believe that this number is very important. It's a really, really big number, in fact. And it's actually a lot smaller. It's a lot bigger than the Google, which is 10 to the 100th power. A lot bigger than Google. But it's still a lot smaller than Google Plus, which is 10 to the Google power. Or let's say, yeah, still way smaller than that. Way smaller than any other famous large number. Despite it's still really big though. Now my phone, on my Motorola phone, can calculate 19,515 factorial. But now that is still a really big number by itself, but I'm just going to do the calculation for you right now on the phone. Okay. Because, yeah, I was about to do it on the phone, but the camera had a bit of a problems, but yeah, that's why I didn't really do it, so yeah. 19,515 factorial. And now that is 6.7580999716 E 75,253, which means 75,253 power. Now that is very big. Now if I go to the next one, which is 19,516 factorial, I get can't calculate, which means then it just tells me cannot calculate. If I go 19,516 factorial, it tells me I cannot calculate. Yeah. If you're wondering what I just did, what I was doing, I just worked that out on my phone. But obviously it's too big for my computer, which I don't know why. Now let me tell you one thing first. Yeah, so that's the truth of factorials. For example, 6 factorial is 6 times 5 times 4 times 3 times 2 times 1, which is 720. And it even works the other way around. You can also do 1 times 2 times 3 times 4 times 5 times 6. You can even go up, which will still give you 720. Now, if I do 6 factorial, what this is that it's basically saying, let's say, 6 factorial is 720. So, 6 factorial, 6 double factorial, that's 6, 6 factorial 1 is 720. So 6 double factorial, 720 factorial. So 6 factorial is 6 double factorial is 720 factorial. So let's go 6 factorial with 720. That's one explanation mark. Add another one, that's 720 factorial. So yeah. And obviously this one will be too big for 3. But yeah. see, I have an overflow because the numbers become too big for the calculator. You see, obviously, so you see what I mean by 6 double factorial. You see, 111. I factored the closest I can get up to probably yeah. So yeah, 3 factorial is the max number I can tripleize in explanation, right? The factorial is basically the number of ways these items can be arranged. For example, if there was a passcode for 10 digits and every digit had to be different, you see I have in a 1 and so if I go 10 factorial, that's 3,620,800. That's many ways to calculate factorials. However, this may be different to passcodes. For example, if I had let's say, a code that had 10 digits and 10 digits, and each digit can be written 10 times, so if someone can have 10 number of zeros, obviously I cannot write 10 number of zeros, which doesn't let me, for example, so I'm going to do 0.0, 3, 6, 7, 8, 3, 4, 5, 6, 7, 8, 3, 5, 9. If you count the first one, that should be 10 altogether. 3, 6, 9 plus 1 is 10. So yeah, so that's 10 digits. If everyone could calculate the 10 digits, that would be 10 to the 10th power, which is 10 billion. So that's 10 billion different combinations. If every digit can be written up 10 digits 10 times, that's now again 3, 6, 7, 8, 9, 10. That's part of it. This number here is part of the 10 billion combinations. So if there's 4 max, we could go. Each number can be written 4 times. If it's 4, that'd be 10 to the power 4, which is 10,000. You see. Now if there was 3, that'd be 10 to the power 3. So you can kind of see what I'm doing right here. So that'd be 10 to the power 3. Come on, raise it. Which is 10,000, yeah. So that's 10 to the power 3, 1,000. That's the 1,000 possible outcomes if there's 10 digits, and I can write each one 3 times. Simple. Each one 1, 3, 2. I can write this as part of this 7 like this. And yeah, I hope that you guys enjoyed the video. So kind of give you a quick brief through what a factorial number is, how much items can be arranged, obviously. Now I am working on my computer on 5 factorial. I was working on 6, but then I moved on to 5. Just a minute, assuming it's this one. Is it that? Yeah, that's the number. So yeah, that's 5 factorials. I've already finished 1s, then the 2s, then the 3s, then the 4s, and I never wrote this. I think this is probably confused it with something else actually. So yeah, so kind of see what I mean by this. So yeah, now on the 4s now, I've got 2 more levels of 4s and 4 levels of 5s, and that's all the factorial of 5. I know there's 120 of them, but yeah. Okay, see you later, bye.